In this video, we're going to take a look at two examples where we are going to use the second derivative test to find relative extrema. And so, to do that, we first are going to take the first derivative. So this first function we're looking at, f of x is x cubed minus 3x squared plus 3. Take the first derivative, we get 3x squared minus 6x. We want to set that equal to 0, so we can factor out a 3x. If we set that equal to 0, then x is 0 or 2. We will also take our second derivative. When I find this second derivative, I would not use the factored form. I would go back to the unfactored form. So here is f of x, 3x squared minus 6. So our second derivative is going to be 6x minus 6. We don't need to set this equal to 0. We just need to plug stuff in. So the second derivative at 0 is negative 6. That's smaller than 0. So we have a maximum. At x equals 0. We will also plug in 2, plugging that into the second derivative. 6 times 2 minus 6, which is positive 6, which is larger than 0. Because that's larger than 0, right at the point 2, right when x is 2, it is concave up, and so it's curved up. So we must be at the bottom of a valley. So we have a minimum when x is equal to 2. So that's our max and min. And we use the second derivative test to find those. Let's look at this second example here. So in this second example, we have a trig function, cosine x minus x. We are only interested in the interval from 0 to pi over 4, 0 to 4 pi. So we'll take our first derivative, g prime of x. Derivative of cosine is negative sine. Derivative of x is 1. We are going to take that and set it equal to 0. So 0 is negative sine x minus 1. So we want to know when is sine x equal to negative 1. Sine of x is equal to negative 1 at 3 pi over 2. It's equal to 1 again, 2 pi later. And so if we were to add 2 pi to that, we would get 7 pi over 2. Those two values are still in the interval from 0 to pi over 4. If you add 2 pi to this again, it would be negative 1 again. But if we added 2 pi again, we would be outside of this interval. So those are the only two values in this interval where we have a potential maximum or min. Now we are going to take our second derivative. So we're taking the derivative of the first derivative. So the derivative of negative sine x minus 1 is negative cosine x. What are we going to do with that? Well, we are going to plug 3 pi over 2 into our second derivative, so the negative cosine of 3 pi over 2. That is 0. Okay, so let's leave that for a minute. Let's look at 7 pi over 2, see if this is any better. And we also get 0. So what does that tell us? Well, that tells us we can't use the second derivative test. At those points, those could be maximums, they could be minimums. So how would you then do that? Well, I would end up going and use the first derivative test. What was the first derivative test? Well, that's where you would do a sign chart. You would see, does it change from increasing to decreasing at 3 pi over 2 or 7 pi over 2? And if we go through and do that, we can find that there are no relative extrema. And again, the way you would go through and find that is you would do a sign chart. And when you do that sign chart on that first derivative, you will find that we always end up with values that are either 0 or negative. So it is decreasing everywhere. All right, we will see you in our next video. Have a good one.